Morning, still with the paper, December 2021, refer to the infographic on South African Berg Winds. Berg Winds, okay. Record breaking, we have got three pieces of information here. We have got this, we have got this, we have got this that we are going to use to answer our question. What is it that we have? Let's go through it. East London residents were subject to sweltering heat last Saturday after a record-breaking heat wave. After a peak of 43.9 degrees Celsius, according to South African Weather Service. The heat wave was a result of Berg winds conditions where hot winds blow down the coast from the high central plateau. So we have got this, we also have this here. So this actually gives an idea what this is all about. And we also have this also, the graph just to show you what this is all about. So you have got three pieces of information. You have got this, you can see the low pressure at the coast. You can also see the changes in temperature, okay, temperature in degrees Celsius, a graph tracking the temperature of East London over the course of Saturday 18 March. Okay, let's go through the question so that I do not waste time. Name two pressure systems that are necessary for Berg winds to develop. So here we have got your Kalahari High, you have got your Kalahari high pressure. This you find in the interior. Then you also have your coastal low. Coastal low at the coast. Here you get it at the coast. Here is in the interior. Okay, that's what is happening. That's your coastal low. Then your Kalahari High will be in the interior. That's basically what we are talking about. Okay, then determine the highest temperature that was recorded on 13 March 2021. 13 March, which means we check here. That's basically what we are doing, which means we have something like, I would say the range of 43, okay, 43.9 degrees Celsius to 44.1 degrees Celsius. That is the temperature that we are looking at. That's the temperature that we are looking at when we consider here. Remember, this is the temperature, this is the day, which means we are saying it's somewhere there. That's basically what we are saying. Okay, then what role did the escarpment play in increasing the temperature of Berg winds between 10 to 14, which means between this range, okay? Between this range, 10 to 14. What role did the escarpment play in increasing the temperature of Berg wind between 10 to 14? That's basically what we are being asked here. Okay, between these hours, of course, what between this hour from 10 o'clock to 2 o'clock, what range did it play? Of course, let's see 1.5.3. The escarpment is because it has got a greater vertical height, that is elevation, that's number one. So there's greater frictional drag as air moves down the escarpment, which results in increase in temperature. Remember, for every decrease in 100 meters, the temperature increased by 1 degree Celsius. So which means that is what we call the dry adiabatic collapse rate. Okay, so air is a greater vertical descent down the escarpment, that is 1,200 meters to 0 meters, and heats up more. That's what we are talking about is adiabatic warming, which means that for every decrease in 100 meters, the temperature increased by 1 degree. Okay, increased heating at the dry adiabatic collapse rate of 1 degree of Celsius for every 100 meters due to a vertical distance of the escarpment. So this is how the escarpment play a role in increasing the temperature, of the Berg wind. So we are saying now, when you're looking from the plateau towards the coast, this is your coast, this is your plateau high. We are saying now, as it is descending the mountain, for every decrease in 100 meters, the temperature, it increases by 1 degree Celsius. So which means, let's say here when it was 20 degrees here, so when it reaches here, let me say maybe it will be 30. I'm just giving this as an example so that at least you have an idea of what this is all about. So as it is descending down the mountain, of course, what is happening, it is warmed up adiabatically, which means for every decrease in 100 meters, the temperature increased by 1 degree. So it means here at the coast, it will be warmer than it was in the interior, where we have got the plateau or where we have got the Kalahari High. So that's basically what we are saying, that the escarpment is a greater vertical height. Okay, we are saying that greater physical drag as the air moves down the escarpment, which also results in increasing temperatures. Air has a greater vertical descent down the escarpment, just from 1,200 meters going downwards, okay, to 0 meters above sea level, heats up more, then increasing heating. The adiabatic lapse rate at 1 degree for every 100 meters due to vertical distance of the escarpment. That's basically what we are talking about here. Okay. In a paragraph of approximately 8 lines, explain the impact of Berg winds condition on the physical and natural environment. So this is a paragraph question, which means you have to answer it in form of a paragraph. So when it comes now to paragraph questions, boys and girls, you have to make sure that you have got the factor and the qualifier, which means your point has to be fully explained. That's what it means. How do you go about it? I'll give you some answers, okay? We are saying the focus is the impact of Berg winds on the physical environment, which means we are more concerned with the natural environment. We are not going to write anything about the economic or anything social. The focus is on the natural environment. What will be the effect? So the first thing is the natural vegetation or the plant's natural vegetation will dry out due to hot, dry winds. So drying of vegetation. How is the vegetation drying? Is because of the hot, dry winds. So drying of vegetation, okay, is the factor, but you have to qualify it, because if you just say drying of vegetation is 1 mark. So drying of vegetation due to the hot, dry winds, okay? Drying of vegetation due to the hot, dry winds, which means the point is fully explained with the factor and the qualifier. Then the next thing is the reduction in biodiversity. There is a reduction in biodiversity, that is both fauna, which is animal, and flora, which is plants, within the natural environment because of the hot, dry conditions. I've explained it also in full. You can talk about the declining ecosystems will be disrupted. Declining ecosystems will be disrupted. Food chains and food web networks, which means going to be disrupted. But the point that we are trying to put across is declining ecosystems, which result in the disruption of food chains and food web networks. Then also we have got high evaporation rates. What will happen to the physical environment? It will reduce the soil moisture content. Okay, high evaporation rate is the factor. Then how is going to be an impact? It will reduce the soil moisture content. Then the next one is the increase in loss of moisture. The increase in loss of moisture, which will result, in soil moisture and soil, which will accelerate soil erosion. Increased soil loss of moisture in soil, which will accelerate soil erosion. Okay, this is the sum of the impact there. Then also the land is left bare and vulnerable, and this accelerates soil erosion, reducing soil fertility. You can see the land is left bare and vulnerable and accelerates soil erosion and soil fertility. Okay, then reducing soil erosion, reducing soil fertility. The land is left bare and vulnerable, accelerates soil erosion, reducing soil fertility. So there's a factor and a qualifier there. Then also high levels of carbon dioxide will increase atmospheric pollution. High levels of carbon dioxide will increase atmospheric pollution because we don't have the plants to actually make use of the carbon dioxide to use it during the process of photosynthesis. Okay, water from the shallow pools, more non-perennial water bodies can evaporate. This is what will happen also in the natural environment, which means now we do not have those perennial waters. We do not have those water from the shallow pools, small non-perennial water bodies can evaporate. That's basically what we're talking about. The natural vegetation is also destroyed by wildfires. There's a loss of habitat or damage to ecosystem due to wildfires. That's something that will happen as well. We can also talk about the increase in carbon dioxide as a result of wildfires impacts negatively on the physical environment. We can also say that wildfires can promote seed germination, among other reasons. So that's what we can actually talk about in as far as this question is concerned. But what I want you to take note of is this is a paragraph question, so it needs a factor and a qualifier. Like for example, the land is left bare and vulnerable and accelerated soil erosion, reducing soil fertility, which means that point is explained in full. Okay, is explained in full. Or if I'm to say another one, I can say that the plants will dry out due to the hot, dry winds. Okay, there can also be reduction of biodiversity, that is fauna and flora, within the natural environment. That's basically what we are talking about. You can talk about the disruption of ecosystems, which will, the decline in ecosystem, which will disrupt the food chains and food web networks. Or they can be high evaporation, which will reduce the soil moisture content, or increase loss of moisture in the soil, which will accelerate soil erosion. That's basically what we are talking about. Of course, when we're talking about soil erosion, we are talking about the disruption, okay, the change in terms of the fertility of the soil, change in terms of the pH of the soil, in terms of the humus content, and so on and so on. That's what soil erosion is all about. So this is it in as far as 1.5 is concerned, which is a question about Berg winds, which is a question about Berg winds. So boys and girls, thank you so much and have a blessed day. I'm done with the first part, which covers climatology, which covers climate and weather. I'm done with that part. I have done 1.1 and 1.2 together. I've done 1.3 on its own. I've done 1.4 on its own. And also I've done 1.5. Thank you so much. Have a blessed day.